Pat asked me this year to kind of turn the lens inward and look, it's easy to talk about what the government should be doing differently or better in space. It's sometimes harder, but maybe more useful for us to look into the industry and say, what is it that we need to be doing better in space? And Pat's remarks about purpose are, of course, very on point. I'm in this business because I think it's very important that we make broader use of space, and that in order to do that, that the cost of space transportation comes down and the frequency of it goes up. So before I talk about what we should be doing better to control our own fate, I want to talk about the fundamentals of this a little bit. I don't think any of this is going to be startling, and some of you have heard it from me before, and it's nothing new. But sometimes it's the stuff that we all take for granted that you have to focus on to get your head around what's going on. So perfectly got the first slide up. This is a point I've made a couple of times. I see it down here before it shows up there. I think it's slow electrons. The numbers here are all notional, and you can draw different graphs, and every different market survey looks different. But I think the fundamentals of the economics of the industry are not broadly in dispute. Right now, the markets that we have in space are relatively cost-insensitive customers. If they weren't relatively cost-insensitive customers, they couldn't afford to be doing business in space right now. And the consequence of that is that if you drop the price of launch by a small factor, like a factor of 2, the number of customers does not double. And from time to time, new entrants come into the market who think this time that will be different. And I think if you look at the launch dynamics over the last 5 years, you see that cycle working itself out once again, just as it did when Arianespace entered the market, just as it did when the Russians entered the market, that the expectations are high and a lot of new people sign up, but by the time the market shakes itself out, the price may come down by 20%, but the volume of launch doesn't go up by 1 over 0.8. And so in economic terms, what that means is incremental improvements in launch cost from the current status quo shrink the market. They don't grow the market. Now, what would you expect to see in an environment that looked like that? You would expect to see very few suppliers. Every time a new supplier entered the market, you'd expect a short price war until somebody dropped out, and then the price would come back up. And you'd expect the kind of things you see in other price-insensitive markets like high-end jets or high-end yachts or high-end cars. You'd expect a lot of focus on value-added services. Do you want a leather interior with that? How much mission assurance do you want? Can we configure you a custom environment? Can we configure you a custom payload fairing? All for a little extra money, of course, because that's the only way that you can squeeze more money out of a market that doesn't respond to price signals in the conventional way. It's fairly broadly understood in the space industry that this is not true forever. That's only true because the current consumers of space transportation services are the price insensitive consumers. As you drop the price further and farther and farther, new users of space transportation become viable. But it's always hard to trust your business plan to that because by definition, there are new users. You can't go to the bank and say, I want to borrow money to build a better space transportation service to address all these customers that currently aren't there. Or at least you can try, but they'll get a good laugh out of the experience. This creates a situation where there's 2 stable states in space transportation: high cost, low volume, and low cost, high volume. And if we can ever make the transition from the one state to the other, the new state will be stable. Because once the new markets have appeared, once the new customers have entered the market, they aren't going to suddenly go away. And once we've made that transition, we'll be in a market like every other market, where if you drop the price, you get more customers, which incentivizes you to drop the price and makes investing in incremental improvements worthwhile. So I call this the valley of death in space transportation, and nobody knows exactly where that price threshold is. But my own assessment is it's somewhere in the $300, $500, $800 a pound range, going to LEO. Or in people terms, it's somewhere between $1 and $5 million per ticket. When you get below that level for an orbital flight, you're in a whole different ballgame from which there is no returning, and which is good because we wouldn't want to return from there. That's the good place to be. Next slide, please. Okay, very rare of me to use slides, but equations don't work in words. There's nothing original in this analysis. It's all in Sanger's 1951 book. Okay, what does it cost to do space transportation at a high level? Well, there's the cost of the ship. Well, what's the cost of the ship? Well, there's a production line of some kind it takes to make the ships. And you take that and you divide the annual cost of keeping that line open from the number of things that you do per year. And then you have to add in the cost of parts and materials that go into that, although that's usually not a big number. It's usually the cost of keeping the production line open that dominates it. And because of that fact, the cost of an aerospace structure in inflation-adjusted dollars hasn't changed a whole lot per pound over history. And I don't see any prospect that it's about to. I don't see a revolution on the horizon that's going to make building a ship of a given size 10 times cheaper. And 10 times cheaper is what we need to get if we're going to cross the valley of death. Does that mean there's not incremental improvements to make? Of course not. There are incremental improvements to make. But there's not things that are going to change the game in saying, we'll just make the ships cheaper to build. If I have time at the end, I'll say why I don't expect the technology to come online that lets you carry 10 times the payload with the same size ship. That's a longer technical discussion, but let me just say, I don't see such a technology on the horizon. So the only number you can change in this is how many of these things do you build per year? Which is the whole game for expendable launch vehicles. That's the whole, all expendable launch vehicles only fly once. So the only big knob you can turn is how many of them do you make, which is entirely driven by the demands of the market. It's not driven by anything else. If we needed twice as many ships, they'd be cheaper. If it's a reusable ship, you then get to divide by the number of flights in the economic life of the ship. That's until it wears out or until the bank wants their money back, whichever comes first. If it's a reusable ship, however, you have to add on that it takes some kind of team to operate it. It doesn't operate itself. So that team has a cost, and you get to divide that cost by the number of flights you get off per year. So again, flight rate is the key parameter. The more often you fly, and with the smaller team, the cheaper it gets. And then you add onto that the cost of spares and propellant, which right now is a negligible item. But if you did have a high flight rate and you could operate with a small team, you would start to approach operations at the cost of spares and propellant, which, depending on your ship and depending on the assumptions you make, is somewhere between $10 and $100 a pound to orbit. That's 2 orders of magnitude, which is more than enough to get us down to a really interesting place to be. So then the only way, not just a way, but the only way that I can see that we can cross the valley of death in space transportation is to get the flight rate up, whether that be done with expendables or reusable or a mixture thereof. Now, there's a technical challenge to that, which I spent the last 15 years working on, and we're making great progress on, thank you very much, which is being able to do it. But the much more interesting challenge is it doesn't do any good to be able to fly frequently with a small team if you don't have a market that requires you to fly frequently. If the ship that can fly 100 times a year that only has 4 customers sits in the hangar and doesn't make any money. Next, that's the end of the slides. There is no physics limit. Unlike there are physics limits on things like ISP and thrust to weight and how light we can make the structure. There are no physics limits that we are anywhere close to on how frequently can you fly, how long can the ship last, and how few people can you figure out how to make it operate. So I have every reason to believe that both for suborbital and orbital flight, we can figure out a way to get those 2 orders of magnitude if we can figure out how to cross the barriers. Now, there are external barriers, or apparently external barriers, or potential external barriers. Regulation could be one, if not for the good offices of George making sure that it was not. What else could stop us? Well, we could fail to get the capital to build the ships that let us cross the valley of death. And that's a significant obstacle. But that in and of itself, I think, is only market risk in another disguise. If the capital markets believed that the markets were there, you'd be able to get the capital to build the ships. One that we don't talk about very much is the debris environment. If the debris environment gets bad enough, that could stop us from building things like that, because it's already a fairly significant design constraint on building a reusable ship. And if as the debris environment gets worse, the constraint's going to get more serious. But leaving that aside, it all comes down to market risk. And we control, by we, I mean the collective space industry, we control what the market looks like, or at least we influence it heavily. Why is it so hard to make the business case that there's 100 things a year to launch, or 200 things a year to launch? Because that's what it takes to make a vehicle that actually has these kind of economical operations. You need hundreds of things per year that have to be launched. We have a reliable, robust market for putting up something like 1 million pounds in orbit per year right now. Okay, see 1 million pounds divided by 100 flights, that's 10,000 pounds, and if we want to do 1,000 flights, that's 1,000 pounds. Okay, what's the problem? There's obviously a market for it. Well, the problem is the market is very fragmented. People don't launch pounds into space. Launch is not treated as a commodity. It's treated as a very specialized service with lots of value added in the leather interior and how much mission assurance do you want, because it's only driven by cost insensitive things. But if we, the users of space transportation, actually wanted cheaper space transportation, we can pretty much have it anytime we want by changing what we want to launch into space. Because if we start launching things into space that are commoditized, there will already be enough volume of traffic to justify investing in ships that give us cheaper space transportation. One example of that is satellites can be launched in pieces. That's a very scary foreign thought to the existing satellite providers. And they don't see a reason why they should right now. Okay, but whichever satellite manufacturers figure out how to launch their large platforms in commoditized smaller pieces are going to be the beneficiaries of the vehicles that come into service to launch smaller pieces more frequently. So either the existing guys will figure it out, or new entrepreneurs can come online, and there are signs that that might be happening, who do figure it out. And it's a detail whether you consider small pieces flying in formation to be the way you attack that problem, or whether the small pieces get together and assemble in some manner and solve the problem that way. I think both of those technologies are interesting. Even though I mostly want to talk about what industry can do, I'll mention in passing that, of course, government could solve this problem at the stroke of a pen, because government is a very large consumer of launch, and if government chose to buy launch in a commoditized manner, the rest of us would be able to follow along in that wake. So for example, if we had an exploration program going and they bought propellant on a commodity basis, that would be more than enough commodity demand to justify there being multiple competing launch vendors to satisfy it. But again, that's out of our control. What's in our control is how we do the commercial segment. The nanosatellite or microsatellite revolution that's in slow progress is another example of that. If people figure out how to do the jobs not by assembling large platforms out of small pieces, but just by launching more small pieces, hey, more small pieces that come out of a commodity interface is all we need to build the business case, we and our competitors, to build the business case to show that these kind of vehicles can be economically put together. I want to come back to debris for a moment, because debris is both a problem and an opportunity. Obviously, we have to do something about the debris environment, even if it's immediately stop making it worse would be an excellent something to do. But even that by itself is probably not enough. It would be a great big help if some of the larger reservoirs of dead mass up there were moved out of the way or brought down. And it's surprising that various government agencies, national, transnational, or international, haven't done something to incentivize solving that problem. But we don't have to wait for them. I mean, the insurance industry is part of the space industry. The large ComSat operators are part of the space industry. It is worth something to get your ComSat down so it can't be a debris generator. It is worth something to get other pieces of junk down so that they don't run into you. It may not be worth a lot, but it's worth something. And there have been proposals that have not been taken up to do risk pools or bounties or something, mostly from the insurance industry end of the universe, where there is some financial incentive to either not leave your debris up there, or to go up and get a piece of debris and get it out of the way. And there are technological approaches to do that. It's not true that we can't think of how to do it. But nobody's going to do it if nobody's going to pay for it. We as an industry and how we choose to monetize our risk is a strong influence on whether it pays to bring debris down or whether it pays to leave it up. And I'll note in passing that there is a fairly large backlog of debris up there, and if somebody comes up with a way to bring a piece of debris down, that's that much more launch traffic, and that much more launch traffic benefits all the consumers of space transportation, because the more often we fly, the cheaper it gets. There is a market for on-orbit labor. One of our investors paid his own way to the space station, Richard Garriott, to find out how much he could make when he was up there. The answer was not $30 million. He couldn't figure out how to make back the price of a Soyuz ticket. But the significance was he did make several $1 million, something on the order of 5. So if the price had been 4, he could have gone every week. On-orbit labor has a value. Doing things, running research, unfolding stuck antennas, putting big satellites together out of small pieces, whatever it is. There is plenty for people to do on orbit that is a paying economic activity that is not just individuals paying their own way because they like to. It just is that economic value is currently less than the price. Okay. Until we get across the valley of death, until we have lower cost based transportation, we can't solve that problem. But the more that we use the scarce on-orbit labor we have now, government, private, individuals who pay their own way, the more of this market proving we do, the more revenue generating activities they do while they're up there, the more it proves the case that if the price were to come down, we'd do a lot more of it. And I'm surprised that more of that isn't done. Our efforts to do more of that on the space station have not been as successful as one might wish. And relatively few of the private individuals who've paid their way up there have thought to use the most of their time to show that we can do revenue generating activities. We, the industry, fly those people. We, the industry, have some influence over what they choose to do while they're up there. We, the industry, have a lot to do with how the commercialization efforts in the space station are undertaken. To the extent that we show that people on orbit are a valuable asset, the more the market is demonstrated, the more we can shift over into the favorable, stable state of high volume, low cost. I'm going to turn my last page here. Propellant is, of course, the ideal commodity market because it's infinitely divisible and nobody cares if you lose a load. Also, it doesn't come in brands. It comes in chemicals, but one company's supply of liquid oxygen is very, very much like the next company's supply of liquid oxygen. So it's a very natural commodity product. My and others' attempts to bring this fact to the attention of our federal policymakers as far as our civil space program is concerned has been wildly unsuccessful. However, the government is not the only consumer of propellant. I am continuously surprised at how slow to embrace the idea of on-orbit refueling, on-orbit servicing, on-orbit end-of-life station keeping, et cetera, the commercial industry has been. There's an attempt going on right now. There have been attempts in the past. But it's a classic, well, we'd all love to use it after it's a proven service kind of thing. Once that service is proven, there is no reason for those tugs, service assets, whatever you call them, to be used once and thrown away. They can come down to LEO and be refueled. I don't care what propellant they use either. We can figure out a way to fly it, whatever it is that they use. That is a fantastic market. It can be served in any size package. So it doesn't matter if the demand in the early years is for only 50 or 100,000 pounds per year of propellant. That can be made in as many rides as you want. If somebody builds a dedicated nanosat launcher, they can bring up propellant 10 pounds at a top if they can figure out how to make money doing that. So it is very much in the long-term interests of the industry for us to think strategically and facilitate and encourage people to get into that market, not because necessarily a satellite provider cares whether that particular satellite servicing operation comes into fruition or not. But once you come to realize that the greater volume of launch traffic that will foster will help lower my price as a launch provider, as a launch customer, there's an extra weight on the scales that should incentivize us to do things that help move the industry in the direction of higher launch traffic. And I will mention in passing also what George mentioned. There is activity going on for beyond Earth orbit. There is unmanned activity being developed on a for-profit basis, and there is, I believe, a fairly significant philanthropic source of funding out there for people who can figure out how to do human missions beyond Earth orbit within the reach of the private purse. That is not easy to do, but the private purse is bigger than it was 20 years ago or 40 years ago. And I think that's a real market. And even one such mission uses a lot of launches because there's limits to how much you can scale down a human beyond Earth orbit mission. So the common theme in all this that I want to leave with, and then I'll either take questions or get off the stage, is the space business, the space transportation business is very, very compartmentalized. And there's a natural tendency for each of the players in the industry, and I do not accept myself, to think about their segment of the market as being the interesting segment of the market. And of course we all think that, otherwise we'd be in a different segment of the market. But it is to our advantage not to disparage the value or validity or existence of those segments of the market that we are not in. Because the rising traffic lifts all the ships equally. So I may not be in the ComSat launch business, but that doesn't mean it isn't a perfectly good business. It's a perfectly good business. It's great. It's wonderful that there are more ComSats. I'm excited about that. It would similarly, you may not be in the business of launching people and payloads to suborbital flight. You may not think it's all that interesting of a market. You don't have to care. It doesn't hurt you to have that market come into existence and be served. It helps you because the more launches that we do, the more engines that we buy, the broader the industrial base gets, the lower the cost gets up and down the supply chain for everybody. So other markets are your friend. It is good for you to have other markets exist and flourish. And that's the message I would most like you to carry away from today. And with that, I will stop and take questions if there are any.
Thank you, Jeff. I have one question from the audience. Could you please comment on the obsolescence of on-orbit assets as a barrier to refueling and servicing satellites?
Okay. Certainly is true that is an issue. It still doesn't change the fact that people rarely abandon on-orbit assets because they're obsolete. They abandon the on-orbit assets because they don't work anymore. And it is economically advantageous to burn the last drop of station-keeping fuel that you have before you give up on the asset. Therefore, there is an economic value to be had, even for a so-called obsolete asset, in not requiring you to keep end-of-life maneuvering fuel and providing the service of getting you out of the way, or if you're still finding the asset useful, extending its life. It might not be as nice and new and shiny as the new bird you could build, but it is up there and it is already paid for. There's an old joke in PGR work that we don't recycle Ferraris, we sell them because they're still useful at the end of your use of them. I think satellites are mostly still useful at the end of our use of them. And even if you, the operator, want to replace it in your very highly valuable GEO-COM slot with the newer, better bird with more transponders, that doesn't mean somebody else in a less served market wouldn't be glad to take it off your hands for a non-zero value if only there were a way to keep it working.
I have another question for you. So speaking a lot about orbital debris and orbital markets. I think a lot of us in the audience are very familiar with the links and a lot of the suborbital activities going on within XCOR. Are there plans to be going orbital with XCOR? Are there thoughts about how XCOR is going to participate in some of the needs of the orbital market?
We started the design of the orbital system before we started the design of the suborbital system. The suborbital system is a revenue-generating Y plane that lets us collect up a basket of the technologies we wanted to prove out for the orbital system and make money from the suborbital markets on the way. So very much we're thinking about the orbital system, which is not to say that the suborbital markets aren't incredibly interesting in their own right. They absolutely are. But I don't need anybody's help to develop suborbital markets. They're already flourishing quite nicely. It's the economic case for a fully reusable orbital system that I think would benefit from more pooling of the demand and less stovepiping of it.
Okay. And so what are you thinking in terms of for orbital systems for you guys? Are you thinking decade away, a couple decades? See how things come along with the links?
I expect to start working on it within a few years.
Great. Excellent. Thank you
Thank you
very
very
much,
much.
Jeff, for your time.